Good morning, good afternoon, and good evening, everybody. Today we have Enterprise Switching Architectures and Best Practices with John Mead, who is the Senior Director of Engineering for our CN Matrix Enterprise Switches. Hi, John.
Hello, Susie. Thank you very much. And hello, everybody. So I was asked to talk to you guys about Ethernet switching. I'll be focusing mainly on the enterprise space, covering features and capabilities that you should be aware of and looking out for. I think everyone knows, or if you don't, I'm responsible for the Ethernet switching portfolio here at Cambium. However, for today's conversation, I'm going to focus on just Ethernet switching in general, not really on the Cambium solution, although I may not be able to stop myself from mentioning the Cambium portfolio from time to time. So a little bit about myself. I've been at Cambium for about a year and a half. I come from the Nortel Networks and Avaya data networking teams. I've been building switches for a long time, 20 years or so. So that's me, and why don't we just jump right into this? Let's see if I can change slides here. Okay, here's some of the things I want to cover today. So I'm going to jump right into the deployment use cases to get a rough idea of how these Ethernet switches are meant to be used. I'm going to talk to you about some of the general considerations you should take into account when buying, purchasing, and deploying these switches, critical factors to look out for, some of the hardware requirements as well as the software requirements you should be aware of. And then I'm going to kind of wrap it up and highlight a feature that I think everyone should be aware of and be looking out for when you do buy your Ethernet switches. And that's related to automation and zero touch. And then at the very end, I'll just put a summary slide up of the CN Matrix portfolio, which is the Ethernet switching portfolio at Cambium. Okay, next slide. So deployment use cases. I really wanted to put out this deployment use case to show the enterprise space that we're targeting and what aspect of the enterprise space that we're covering. We won't be talking about all the switches, of course. So to begin with, this is a typical enterprise campus deployment. It's a three-tier network architecture. And what I have shown up here is just the core of the network. This is going to be one main switch or maybe a matrix of switches. And of course, you'll have some type of WAN connection to the internet. The next tier in this architecture is the distribution layer. This distribution layer is optional. Large companies will have a distribution layer of switches. Some companies will skip this layer and go right to the access or to the edge of the network. And that is the next tier in this architecture, the access layer or the edge of the network. The access layer consists of your basic L2, possibly L3 capable switches. It also includes your wireless access points as well. You want to be able to provide both wired and wireless connectivity for the devices and users. And I'll go into more of that in more detail. So this is the three-tier architecture. Another aspect is the management. You need some type of network management system for your network. And I just displayed in the upper right corner there some type of cloud-based network management, or customers may want an on-premise network management solution. So this is key. So when you go out and you select a network management system for your network, do you want to run it remotely in the cloud, or do you want it on-premise? And you should look for options that give you both alternatives, and you want to make sure that both of those solutions are the same solution. So if you choose the cloud solution, you don't want to have different capabilities and different features and different nuances as compared to the on-premise version. So it's nice if a company can offer the same solution that can run either in the cloud or on-premise. So that is key. So what am I focusing on this slide and in this presentation? I'm going to focus on the access layer. So again, this access layer is a key part, and I'm going to go into details on this. The access is where you provide connectivity to all your users and devices. It has wired access with your L2 switches, as well as wireless access with your access points. Another key component of this access layer is how you're going to manage it. So again, I've highlighted those network management systems, either on-premise or out in the cloud. An interesting little fact about the access business, it's from analysts, it's not from me. It's about a $14 billion market. About $8 billion are for the switches. Now, these are just the switches at the access layer. They're not, it does not include data center switches, does not include switches for the core, it does not include distribution switches. So only the access layer switches, about $8 billion, and then the wireless access points, about another $6 billion. And let's see, a little bit of a plug for Cambium here. These L2, L3 switches, the C and Matrix portfolio from Cambium, as well as the C and Pilot access points. And again, our network management solution here can run on-premise or in the cloud with C and Maestro. Okay, next slide. So this is another picture, very similar picture for a smaller company, a smaller rollout. But again, from an access layer point of view, it's the same. You still need your wired access. You still need your wireless access. You still need some type of management solution. This next picture shows, it's definitely an enterprise deployment, but they're branch offices. So each office might only be 20 employees, 30 employees, 40 people, whatever. But you have a bunch of them. For example, Bank of America, I don't know, 500 branches across North America. So you'll have this duplicated here, but it is an enterprise deployment. At each branch office, you still have the same requirements at the access layer or the edge. You need your wired and wireless switching. All right, a few things to consider when looking at your access switches. First of all, at the edge of your network, that's where all the action is, right? Day-to-day operations, maybe not daily, hopefully not daily, but there are a lot of changes going on at the edge of the network. You're adding new devices, you're moving devices, you're removing devices, maybe you're rolling out new services to give different access privileges to devices, so on and so forth. Whereas in the core of the network, it's more stable. Once you have it set up, very important, you get it set up and operating as you want it, it's usually pretty stable over time. The edge is where all the action is. So wired and wireless at the access. Wired and wireless, it is not two different solutions, two different sets of products. When you go out and deploy your access layer, you need to be thinking about wired and wireless as a single solution. If you go back, I don't know, 10, 15 years, they were two separate solutions. You'd go out there, you'd buy your wired solution and deploy it, and then as an add-on, you'd add in your wireless capability as well. You don't want to do that anymore. You really want to buy this as a single solution. You want these products to work seamlessly together. It really is very important. You want your QoS and access privileges across your users to be the same, whether they're connecting to your network via the wired interface or the wireless interface. You want QoS to be consistent. Okay, again, at the access layer, it is an advantage if you buy your products from the same company, for maybe not for the entire network, but for at least the access layer. So, the wireless access, as well as your management, nice if it comes from the same company. Those three elements fit very well together. The products purchased from the same company, from a single vendor, seamless integration. They've, of course, been designed to work with each other, tested to work with each other. It's just a more simpler deployment for you. If you do have issues, if you do have questions, getting support is much, much easier. I mean, a lot of times when you're having problems in your network, it's hard to really know exactly where the problem is. Is it on one of your edge switches? Is it on some aspect of your wireless network? Is it related to your distribution? But, with a single vendor, it's one phone call that you make and you work with that one vendor to solve whatever problem you have. Maybe it's not a problem, maybe it's an enhancement that you want, but it's still one vendor that you're interacting with. Another aspect of getting this access layer, the wired and wireless solution from one company is the products from that company are often designed to work together, and they often work together better than if you would buy them from two separate vendors. So we talk about it internally a lot. you get extra features. You buy your wireless access point, you plug it into a switch from the same vendor, you often get features. It's 1 + 1 = 3. Also, when you're configuring your access points or configuring your switches or maintaining them or managing them or monitoring them, having a single and consistent user interface is also important as well. Okay, so what kind of features and capabilities should you be looking for on these switches? So these are edge switches, L2, right? So layer 2 features, not a lot of rocket science here. L2 switching has been out there for 20 plus years. It's a long list of features, and you need to have them for your switch. And it doesn't matter what vendor you go to, most vendors will have all the L2 features that you need. The next kind of category of features fits into L3. So do you want to have layer 3 switching at the edge of your network? It is not critical, it's not mandatory, but often a customer will find themselves needing L3 switching at the edge. Maybe not on day 1, maybe not on day 2, but down the road they might. It's not a significant increase in the purchasing decision or the purchasing dollars to add an L3 into your switch, and it is a really good idea to future-proof your network with this L3 capability. There's several levels of L3, and at the edge, there's static routing only, might be good enough, or there's static routing with dynamic routing as well supported. A lot of switches will support both static and dynamic. A lot of switches will have L2 only. So with the dynamic routing, at least some of the basic protocols, RIP, OSPF, you should be keeping an eye out for things like that. One more aspect to think about when looking at the L3 capability of your switches is the number of routes that you support. Is it 16, 32, 64, some small number of routes might be okay for some deployments? Or is it more significant, 256, 512, or 1K routes? It really depends on the specific deployment. At the edge, 256, 512 should be fine. When you start moving outside of the edge, outside of the access layer, maybe up to the distribution layer or to the core, that's where the scaling numbers are going to be much more important. So 512 might be enough at the core for some small companies, or you might need 8K or 16K for larger tier 1 enterprises. So security features, next category. Obviously very, very important. Whatever switch you end up buying, make sure it has the security features that you need in your network. Access with access control, 802.1x for users and devices, or monitor control with username and password. Often has different levels of access depending on the username and password, so on and so forth. But security is also very important. Keep an eye out for that. Another aspect that you want to look at is QoS, so quality of service. Do you want to be able to prioritize your traffic? Do you want to make sure your video and voice is high priority? Do you want to be able to prioritize the traffic accordingly? So look at the QoS capabilities of the switch. Look at the access control list capability and the filtering capability of the switch. A lot of vendors will use these features to supply more advanced capabilities as well. Okay, last bullet I have here is about management. Very, very important. So management on these switches come in all kinds of shapes and sizes. There are switches that you can buy that are unmanaged. There are switches that you can buy that are smart managed, which is one notch above unmanaged. For an enterprise network, you really want a fully managed switch. And when I say fully managed, I'm talking about a comprehensive COI that gives you access to the features and capabilities of the switch. There are a lot of power users out there that love COI. Also, a lot of users out there love they enjoy a more a friendly interface with something like a web GUI. Still, a lot of customers out there use some type of SNMP based application to manage their switch. And then at the top, all the COI, Web GUI, and SNMP that I've mentioned so far is more for device management, so management of a single device. You also need some type of network management system as well that can manage multiple devices, monitor multiple devices, as well as configure multiple devices. And what I mentioned earlier in the beginning is this network management system traditionally, up until about 10 years ago or so, was always on-premise. More and more people are wanting to take their management solution out into the cloud for managed services and other benefits. But again, that network management system, whether you choose the on-premise version or the version out in the cloud, very, very important that is the same network management system, has the same capabilities. It's kind of awkward. It's like putting a square peg in a round hole. The network management system that's designed for on-premise at some companies may not work so well in the cloud, and vice versa. So keep an eye out for that. You want a network management system that works equally well in the cloud as well as on-premise. Okay, total cost of ownership. Keep this in mind. You go out there, you shop for a switch, and you see a switch price for $500 or whatever. That's not the final price of that switch. So a lot of the features on that switch, software features, might be licensable or might be licensed by that vendor. So you buy the switch for whatever, $1,000. Well, to get the feature that you want, you might have to buy a yearly license for another $100 or $200. So software features that maybe like on these edge switches, L3 is not really expected. So some vendors might charge extra for that. Or some advanced features, like some automation features that I'm going to talk about later. Some vendors will charge for that. For the network management system, if you want to run your network management system out in the cloud, some vendors may charge a license for that as well. Or what else? So warranty. What's the warranty package? Is that extra, or does it come with the switch? On the hardware side, I don't see this as often, but I'll talk about this on the next slide. But some switches will have SFP plus or 10 gig uplinks. However, the vendor might throttle that 10 gig down to 1 gig. And if you want 10 gig, you might have to pay a license for that to get that 10 gig uplink. Some companies will include all of that for the same base price of the switch. Some companies will, pay as you go. So for all those things I've mentioned, you pay extra. So keep an eye out for that. Support, again, is it easy to manage your switch? This is an important one. I'm going to go into more detail on the next slide, but is it easy to manage and maintain your switch? So how much of the IT team's time is it going to take to manage your network and to manage the switch? Another important consideration that all rolls up under the total cost of ownership. Okay, so support. Another thing to keep an eye out for. If you have problems with your network, it's not very often that you know exactly where the problem is. It's usually, hey, my network is dropping packets, it's not performing. You don't know where the problem is. So how do you troubleshoot the network to narrow down the problem? Hey, it's related to this one switch or this one aspect of the network. So when you call for help, you want to have a decent support from the vendor that you've chosen. Does the vendor have a phone number that they answer? Is it reliable support, dependable support? Are they responsive? When you do log a ticket or log a problem, are they proactive? Do they get back to you in a rapid manner of response? Another aspect of support is the product portfolio. Is it an active portfolio? Are they going to come out with regular software updates, regular software features? Are they going to come out with maybe new hardware SKUs, models? So look at the roadmap from the vendor you're looking at. Do they have an active roadmap with releases coming out on a regular periodic basis? Warranty, I mentioned that before. There's a lot of different warranties out there. In switching, standard 1 year is pretty common. A lot of vendors, not a lot, but a fair amount of vendors also will offer a limited lifetime warranty. Some vendors will offer that for an extra charge. Some vendors will include that as in the base price of the switch. Okay, next slide. 4 critical factors, and this is what I use at the very beginning of a program before the switch is in the concept phase of the switch, when you're designing and architecting the switch. These are the 4 critical factors that I look at from the very beginning. So number 1, quality. Maybe kind of not very interesting and exciting to talk about. All vendors claim they have high quality, but dig into this one, right? It's important. You want a switch that is dependable, reliable, and robust. You don't want to spend your IT team all their time debugging the network and debugging these switches. Number 2, ease of use. So simplicity, probably one of my favorite terms, but you want to make sure it's simple. Things are simple. You want to make it so that the switch, the network, is easy to configure. So that includes, different management options, different interfaces, and also some automation. I'll talk about that more in a little bit. Easy to deploy. So when you deploy your switches, how much of a headache is it to get that switch up and running and online and configured with your base initial configuration? So a lot of people refer to zero touch for the initial deployment, and I'll talk about that later. Again, under the theme of ease of use, so easy to maintain the switch, easy to monitor it, as well as easy to troubleshoot. And again, I'm going to emphasize this one. Are you troubleshooting the switch or are you troubleshooting the network? A lot of times you don't know where the problem is. So if you have utilities or diagnostics tools in your network, either from your network management station or from the switches you buy, do they provide the utilities and diagnostics to troubleshoot the overall network to narrow it down to where the actual problem is? Third critical factor to take into account, you want to buy a switch that meets your use case requirements. What about the hardware capabilities? Does it meet your requirements? I'll go into that on the next slide. Software requirements, does it have the features that you need? For example, I talked about L3 earlier. Do you need L3? Well, you need to look for a switch that has L3 support. Number 4, you can buy a pretty generic switch, and that covers the first 3 items. Number 4 is important as well. Look at that switch and look to see if they have some interesting innovation, some interesting applications and features that differentiate it from the more general switches in the market. I've listed a few examples here. Advanced applications, features and apps that make it that create a simple environment for your switch, for the managing and monitoring of your switch. As you go through your day-to-day operations of your network, as you're adding devices, removing devices, has that vendor provided extra utilities to make it more plug and play and to make it truly a zero-touch experience when you're adding new devices? And then another important category, I mentioned security before, and it is an important one. So this vendor that you're looking at, what have they done from an enhanced security point of view? Okay, next slide. The hardware requirements. Sorry for the small print on this slide. I hope you guys can see it. So the switch architecture. What is the fundamental architecture of your switch? There's 2 fundamental approaches. Silicon-based, so you're really implementing the switching capability, the switching mechanism in hardware. So it's silicon that implements that switching. And the benefits of that is it does give you higher performance and a feature-rich switch. You can do a lot of things in that silicon that you could never do in software on a CPU. But that is the second option here, is a software-based switch. So you have a larger than normal CPU, quite large actually, to implement the switching functionality. You do run into problems. That has some advantages. It may be more flexible. but you do run into problems as far as it's hard to support all the features from a line rate point of view. If you take a 24 port switch that has 4 10 gig uplinks, what is that? 64 gigabits of switching, or it's full duplex, so you could think of it as 128 gigabits of traffic. Having a large enough CPU to process each one of those packets is next to impossible. So you have to take that into account if you're buying a software-based switching solution. Second main bullet here is the ports. A lot of things to look at. How many ports do you need? So you have access ports, and then you have uplink ports. You need eight ports is a pretty common number for access ports, or do you need 24, or do you need 48? So think about that. Think about the uplinks. I'm going to touch on this a little bit more. So how many uplink ports and of what speed do you need to handle the number of access ports that you have? Type of ports, fiber, copper, RJ45 copper ports, or fiber ports, SFP, SFP+. I'll talk more about that later. And the port speed. So all kinds of variations out there. Fast Ethernet or 10100 megabits per second. Kind of old school. 10 years ago, people thought that was going to die away, and those switches are still out there in high volumes. But what's more standard, what's more typical today is access ports that are 1 gig. So 10, 100, 1000 megabits per second. And the price difference between a switch with fast Ethernet ports and a switch with 1 gig ports, that difference in price over the last 10 years has come significantly down. So it's not much more at all if you want to get that 1 gig capable switch. Okay, what else is there? Well, new standard came out. Oh, geez, don't quote me on when, but over the last 3, 4, 5 years, 2.5/5 gig, 802.3BZ. This standard came out mainly from driven by the access points, the 11AC standard that in theory can demand more than 1 gig per port. So they created the standard, and what's key about the standard is 2.5 gig and 5 gig. It runs over the existing wiring in your building. So if you buy a new switch and a new end device, boom, you got 2.5 gig. You don't have to rewire the building, which would by far be the highest expense if you needed to do that. So this standard, 2.5 or 5 gig over the existing wiring in your building. So on your switches, you may want 2.5 gig capable ports, especially if you're rolling out 802.11ac access points or the up-and-coming 802.11ax access ports. That's when you might want to look at switches that have 2.5 gig capable ports. There is an increase in price, and as these get more and more adopted, the price will start to come down. What else? There's 10 gig capable ports. You have 10 gig copper as well as 10 gig fiber. On the fiber side, you have SFP, gives you fiber connectivity at 1 gig. SFP Plus gives you fiber connectivity with 10 gig capability. There's also 40 gig capability with QSFP, and then you have 25 gig, 50 gig, and 100 gig, more for data center capabilities. Again, focusing on the edge of the network or the access layer of the network, at the edge, you're going to have uplinks that go up to the core of your network, and you can have that with a bundle of 10 gig uplinks, which is pretty typical. If you need more, you can look at 40 gig or 25 gig. So uplink requirements, non-blocking. So let me touch on this a little bit more. So I have a picture of a switch there in the upper right corner. It has 24 access ports, and it has 4 SFP plus uplink ports. So if you have 24 access ports, I mean, in a typical environment, you're not going to have 1 gig on every port simultaneously, but there will be bursts and so on and so forth. So in theory, you could have up to 24 gig of traffic. So you want to be, and you will never have full 24, but up to 24. So what do you want to use for uplink ports? Do you want to use a couple 10 gig uplink ports? You could create a link aggregation with 2 10 gig uplinks, and that gives you 20 gig of bandwidth. That 20 gig is probably pretty good. Now you have two ports used in that link aggregation, so if one fails, you still have a 10 gig uplink. That's pretty good. Or you could build a link aggregation, like in this picture here. You could build a link aggregation for your uplink using all four. So now you have a 40 gig uplink to handle your 24 gig of traffic. Awesome, no problem at all. If one of the links goes bad for whatever reason, you still have 30 to go. So in this example, I keep referring to these uplink ports as being SFP plus or 10 gig uplinks. You will find switches out there with one gig fiber uplinks. So if you have two 1 gig fiber uplinks, that gives you 2 gig of uplink. Or if you have 4, that gives you 4 gig of uplink. In some deployment scenarios, you'll be okay. But it's kind of a little bit scary, right? You have a possibility of 24 gig trying to go up a 2 gig pipe or a 4 gig pipe. It's something that you really need to be careful about if you're going to buy a solution that only has 1 gig uplinks. Okay, next bullet, PoE. So power over Ethernet. It's been evolving since the early 2000s with 802.3 AF. Gives you about 15 watts per port of power to power up the end device. 802.3 AT came out that gives you up to 30 watts, and now there's the BT coming out that gives you up to 90 watts per port. So PoE is extremely popular. In the last 20 years, it's evolved over time, but I think vendors probably sell 60, 70, 80% of the switches they sell are PoE capable as compared to non-PoE switches. So your access points, they are most commonly powered up via the power over Ethernet coming over on the Ethernet. Having to run power through your building, through your ceiling to your access point is not desirable at all. So PoE is very, very common. I'm using access points as an example, but geez, there's so many devices out there that can be powered up with PoE. Video surveillance cameras, and I'll use that as an example. If you have a camera that's pointed in one direction, how much power is it going to draw? I don't know. It depends on the camera you buy. 5 watts, maybe 10 watts. However, if you have a camera that has mechanical motion or mechanical capability, it's going to pan and zoom. That's when you really want to start looking at needing more watts for those ports, 20 to 30 watts. So there's another type of PoE. This is my second sub-bullet here, passive or non-standard. So these devices don't follow the 802.3 AFAT BT standard. They're more of a passive PoE. And there are still a lot of devices in the industry today that take passive PoE. So take that into consideration. Think about the devices that you're going to want to power up. Do they require passive PoE? If they do, you need to find a switch that supports passive PoE. So on the same topic, third bullet, PoE, the power budget, the overall power budget of that switch. If you have an 8-port switch and your overall power budget is 80 watts, you have on average 10 watts per port. However, some ports will only draw, like an IP phone, for example, could draw as little as 2 or 3 watts. If you have an IP phone that has a nice visual display, it's gonna pull more power. But anyway, some devices might need 2 or 3 watts per port. Some devices might need 25 to 30 watts per port. So think about the type of devices you're going to plug in and look at the spec of the switch and what is the overall power budget. So in my example, 80 watts over 80 ports, that in most switches, the power is not dedicated, 10 watts per port. It's shared. So while one port is pulling, 3 watts, another port could be pulling 30. So anyway, that 80 watts in my example is shared across all the ports. Now 80 watts, that was just my example, so the math was easy, but 80 watts isn't very much. On a small 8-port switch, you want, 80 could be fine in some cases. 100 watts probably fine. A large 24-port switch, you're going to want quite a bit more. 300 watts, 400 watts is probably pretty good. But again, it depends on your specific deployment. A 48 port switch, a lot of vendors will use the exact same power supply that they use in their 24 port switch in their 48 port switch. So the average amount of power per port is divided in half. So keep an eye out for that. But again, it depends on how much power you're going to need in your deployment. I wouldn't cut it close. I would design in some extra power just in case. So anyway, a 48 port switch, instead of having 300 or 400 watts, look for something that has between 600, 800 watts, or maybe even a removable power supply, so you can replace your power supply with larger power supplies if you do need more power for your deployment. So again, final bullet on PoE, the control is important, right? If you're supplying power to a device, that switch that's supplying that power, you really want to be able to control that power. Enable it, disable it. Very, very common troubleshooting technique is to turn off the power to that device and then turn it back on, which enables you to just power cycle that device if it goes out to lunch and is having problems. Getting stats, how much power is your switch actually using on a per port basis? If the switch and the devices, if all the devices together are consuming more power than the switch has, well, you need to turn off the power to some of your ports. So it's important to be able to have a priority of these ports and to be able to prune or remove the power on a priority basis. Okay, let's see. Other things to consider from a hardware requirements point of view. The environmental aspects of the switch. Is it indoor switch, outdoor switch, temperature, weather, dust, etc. Now, some of these switches will have a USB port on the switch. It's a nice to have. Helps you with file management, file transfers, error log files, config files, or operational, the executable image file, so on and so forth. Out-of-band management port, I don't know, maybe half the vendors out there will have a true out-of-band network management port. Very useful for backup. If your network does go down for whatever reason, you can still access that switch remotely using your out-of-band network management port. Of course, and all switches that I know of has a local RJ45 console port. LEDs, very, very useful actually. System status LEDs, is the switch stuck in boot? Is it stuck in diagnostics? Or is the switch up and running on a per port basis? Are you running at a gig speed or 10/100 speeds? Are you supplying PoE to that port? So on and so forth. And then you may need, if your switch is going to go out in a conference room or something like that, you may need some type of Kensington lock on the switch for security purposes. Okay. I think I'm running a bit late, but we're wrapping up here. So there is one feature, one capability that I'd like to highlight, and that has to do with automation. And this kind of falls under the theme of ease of use or zero touch. So when people hear about zero touch, what does zero touch do for you? Well, it automates the configuration that you would normally do manually. Zero touch initial deployment. So when I initially deploy my switch, that base configuration that I want on my switch, how do I automate that? Well, some of the configuration that you're going to want, I have some examples here on the slide. Static VLANs, uplink ports. Do you want to create a link aggregation, IP address? You could get that through DHCP, or you might want to configure it statically. But anyway, how do you get this initial configuration onto your switch? It's a question you should ask yourself when you're looking at switches. It's different with each vendor on how they accomplish this. Most vendors claim they support this, and most vendors do support this. It's pretty straightforward. And then most vendors will claim, yes, zero touch, we got it. However, this is only half of the story. There's a second component to zero touch that I think of this as an umbrella or two pillars to the zero touch foundation. And the second aspect of zero touch is, what do you do on the day-to-day operations of the switch? So a few examples. So when you're connecting new devices into your switch, every time you connect a new device, you're going to need some type of configuration on your switch. You want that device to be a member of certain VLANs, as an example, or maybe you're going to have some QoS settings or some security settings. So every time you plug in an access point or a security camera, you're going to want to configure your switch. So if you want to make that a zero-touch operation, how do you automate that configuration? It's a very interesting question. We do have a solution here at Cambium. I won't go into it here, but this is part 2 of zero touch. And be sure to ask about this when you talk to vendors, when you are considering switches for your network. On the right, I have various examples, connecting different devices. So IoT, if you start talking about IoT, there's thousands of devices you could connect into your network. The lighting system might be, you might have PUE powered lights in your building. So when you connect in the light into the network, you want those lights to be automatically put onto the building infrastructure network. So anyway, you want to be able to automate all of that. Removing devices from your network is also very important. So removing the configuration is maybe as important or more important than automating the initial configuration. So when you remove a device, you don't want the VLANs that have been configured for that device to be left open for the next device that plugs into that port. So from a security point of view, it's important. Also just maintaining the configuration of the switch, keeping it simple, keeping it maintainable. So what is the solution? There are solutions out there in the industry. Cambium has a solution. Very few vendors actually do this. I can't think of really any examples, but anyway, it's a nice to have. Keep this in mind. Let's see. And now I'm going to give a little bit of a plug on the CamBium switches here. So here are the switches that we're currently shipping. We've been at it for a year now. We've been shipping for about 3 months. There's a lot more switches to come, but here are the 4 models that we're currently shipping. A real quick summary of their capabilities. These are enterprise grade layer 2 and layer 3 functional switches, cloud management in general from a system network point of view, either on premise or via the cloud with CN Maestro. And ease of use, big factor in the Cambium switches. So not only for initial deployment, but using our policy-based automation feature, you can really automate the day-to-day operations of your switch. Enhanced security, part of this PBA feature is profiling the devices that connect to the switch and auto-segmenting them into the correct networks. So working with a vendor that has a complete story for the access layer. Here at Cambium, we have CN Matrix for the wired switches, CN Pilot for the wireless, and then CN Maestro as a management solution. Plugging all of this together really does offer a best-in-class total cost of ownership. All the things I mentioned that comes with the base price of the switch, limited lifetime warranty comes with the base price of the switch, and Cambium is known for very good support. Okay, I think that wraps it up. Q&A. So, Ray, over to you, I guess.
Yeah, John, we do have a couple of questions that have come in. When you were talking about selecting a switch, you mentioned quality and said, check for dependability, reliability, and make sure it's robust. In today's world, I don't know that anybody puts on the side of their box that they don't have those things. So what's a really good way for somebody to go out there and tell whether something is dependable, reliable, or robust? Do you just go to forums and communities, or what can you do?
Yeah, thanks, Ray. It's a great question, and I do not have an answer, but let me take a stab at it. So you're right. So all vendors are going to be attempting to will claim high quality. So what I would recommend doing is, you go online, you look at a switch, looks like it has some good features, and you buy it. I don't recommend doing that. I recommend getting a switch in your lab, firing it up, playing with it, configuring some of the features, letting it run for a while, get a feel for it. Is the switch solid? When you unbox it, you take it out of the box. Does it look like there's been care and time and energy put into that? You get a good feeling when you take that switch out and it's solid. You fire it up and things work smoothly and it's easy to use. So I guess, and you won't know for sure until you've been running the switch in your network under various conditions for 3 months or 6 months. So do as much testing as you can ahead of time. And then what you said, Ray, I would check the forums and try to get information that way as well.
Okay. I guess one other one that we had that came in actually in our community, so I'll do a plug for that. Not everybody would like to have a homogeneous network where I've got these types of APs, I've got these types of switches, and that's all I've got within my one building. But if somebody's a managed service provider, or if you find that the network is evolving over time, chances are you're going to have a mix. What's the right way to drive a strategy to say, okay, here's how we get from where we are to where we want to be? What's a good logical paradigm to think of?
Yeah, so the vendors, the switches that you buy, you need to make sure that they follow the standards and that they can interoperate with other equipment, because you're right. Ideally, you want a single vendor solution, but it's very common that you won't have it. So you need to make sure it works and plays well with other vendors' products. And what you're going to get is a 1 + 1 = 2. The network is going to work for you. But if you really want that icing on the cake, if you can migrate to a single vendor solution, and that's why I really focused on the access layer, right? So if you try to get your entire network to be a single vendor, it's an almost impossible task for the reasons you mentioned. But if you could focus at least on the access layer and solve that part, like what I discussed earlier, at the edge of your network, that's where all the action is. That's where your day-to-day changes are going to happen as you deploy new devices or remove devices, so on and so forth. So, the next time you're going to do a refresh of your switches, maybe you can use that as an opportunity to go with a single vendor solution. Or as you add another building to your campus, that's an opportunity to try to focus on a single vendor solution. So those are a couple tips.
Okay, and I guess one other question would be when you're shopping and you look at the list price, and I think you mentioned some of the options to make sure you get the options that you need that meet your application. And then also kind of take a chart about, what are the additional follow-on license fees, and then take a look at what is the warranty. Are those the main buckets that you would consider when you're taking a look at total cost, or is there something else that people should factor in?
Yeah, those are the main items, and it's really easy to just look at the price of the switch and go, whoa, hey, cool, I'm going to go for it. You got to look at the other. You got to, open up the hood and look inside. I mentioned a couple examples, and those are I probably covered 90% of it, right? But so the extra features, the more advanced features, yes or no? Do they require a license? To enable all aspects of the hardware, yes or no? Does that enable a license? And then the next real big one is management, right? So let's say you do want cloud-based management, and that's becoming more and more common. It's very common already on access points, wireless access points, becoming very common on switches as well. But if you want a cloud-based network management system, is that an extra license? In some cases, it's quite a bit. With CamBium, it's free. Let's see what else. Then there's support and warranty. Sometimes those are tied together, and I'd say that's the next big ticket item. And I think that covers probably 90% of the total cost of ownership. I guess the one additional one I would add is the ease of use theme, right? How much time and energy are you going to spend managing your switch and configuring it and maintaining it and troubleshooting it? That could add up to be the biggest cost of all. So take that into account as well.
Great. Well, thanks very much, John. We don't have any questions in the queue at the webinar, but for anybody listening online, if you have a question, you can go to our community at community.cambiumnetworks.com. Go under the CN Matrix area there. And John's been very prolific in answering extremely detailed questions. Thanks, everybody. We look forward to seeing you on a future webinar. Thanks again, John.
Thank you, everybody. Bye-bye.